So welcome to Unit 9. We are going to be graphing rational functions. We've talked about rational functions before, but a rational number is any number that can be written as a fraction. So when we look at rational functions, we're going to be looking at fractions, functions that are fractions. And if you just scan through well, the first two problems, because you don't have the sheet in front of you, sorry, or maybe you do if you printed it off, but you're going to see that you're going to have a numerator and a denominator to deal with. Well, what happens when you deal with a denominator is there's always a potential for this to be undefined in the denominator. So we're going to end up having some asymptotes involved. We're going to actually have two different asymptotes. We'll be looking at vertical asymptotes. That happens when the denominator is undefined, as well as horizontal asymptotes. And horizontal asymptotes give us our end behavior. And I think I warned you in a video a while back that we'll be revisiting the limit as x approaches infinity when we are graphing, because it's going to tell us how this function is going to end on the far right and the far left. So I'm going to go through a few things that we're going to want to make sure that we find. And it's always amazing to me when we do this, like we can find a few little key things and it's going to be enough. It seems like it's not enough, but it's going to be enough for us to sketch a graph. The one thing that we are going to start with the knowledge of is the parent function f of x equals 1 over x. And that's an Algebra 2 topic that I just want to relive. And that function looked like these two little swoopy things in the corner. And so our graphs are going to follow a very similar feel. Now remember, as you change the numerator and the denominator, things move over and move up. And if I have two quantities in the denominator, I will have multiple vertical asymptotes potentially. And so like all those little things are going to come into play. So let's just jump in. For starters, there are just a few steps that we have to follow, and the first one is factor the numerator and the denominator if possible. So that's going to be my first move always. I'm going to factor the function if possible, because potentially I'm going to be able to cancel some things out, which would be really nice. And so then the second thing that I'm going to try and find is my x and y intercepts. Let's start with the x-intercepts. Those are also known as the zeros. So I'm going to try and find zeros. Zeros happen when the numerator is set equal to 0. And so my zeros are, again, this is an AKA, these are the x-intercepts. That's the other name for those zeros, x-intercepts, where it crosses the x-axis, essentially. Then the third thing we're going to look for is the y-intercept. That doesn't have a fancy name, it's just the y-intercept. And the y-intercept happens when you replace x with 0. So it's f of 0 is what you're finding. So you were going to replace x with 0. Okay. Then the next thing that we're going to do, I number these. I should warn you of that. I number these only because I'm going through, these are steps that we have to follow, but there's really, other than factor first, there really isn't a specific order. If you're like, I really want to find the y-intercept before I find the x-intercept, great, that's fine. The order that you find these don't matter. We'll just put them on the graph and get everything put together. So the fourth step then is finding the vertical asymptotes. Asymptotes. And that happens when the denominator equals 0. And then lastly, we'll find the horizontal asymptotes. And that happens when we take the limit as x approaches infinity of the function. Now I want to spend just a moment of time on that. When you are finding a horizontal asymptote for the graphs that we're finding, again, that's going to give us our end behavior. So the limit as this function approaches infinity is 0 because this is bottom heavy. I hope that rings a bell from the last unit. This is bottom heavy, and so it's going to approach 0. So you can see my end behavior on the right. This is going to come down and just sort of hover above y equal to 0, and on the left it's going to head out and hover just below y equals 0, and that's because the limit of that. Now we're going to be finding only one horizontal asymptote. It's going to turn out that the limit as x approaches positive infinity and negative infinity are both the same for this type of problem, but that's not always the case. You can graph functions that have a limit as x approaches positive infinity that is one value, and a limit as x approaches negative infinity that is another value. But again, that's not the case that we're going to have. Ours are going to be the same, but I just wanted to remind you or let you know that that's not always how it is. Okay, so just be warned. All right. So now I've talked a lot. Let's just jump in. After I've gone through these things, the rest of these I think should go fairly quickly because we'll just do all the steps and then we'll put it together in the graph. So I'm going to go ahead and factor if possible. So in my first step, my function is going to be rewritten as 3x minus 2 over x plus 1. That's the best I can do for factoring, and in fact this didn't even really help me at all because there's nothing I can cancel out. But I did it anyway, so there I am. So then my next step is to find my zeros. I set the numerator equal to 0, so I do 3 times x minus 2 equals 0. I set both of the factors equal to 0. 3 equals 0. Well, that's never going to happen, so I can ignore that. X minus 2 equals 0, and that happens when x is 2. And so I have a 0 here at 2 comma 0, so that's where it crosses the x-axis. So my third move is find the y-intercept. That means I replace x with 0. So in the whole function, f of 0 becomes 3 parentheses 0 minus 2 over 0 plus 1. And when I do my math on that, I get negative 6. 3 times negative 2 divided by 1. And so my y-intercept is at 0, negative 6. Okay, so cruising right along. I do my vertical asymptote 4. That's the denominator equals 0, x plus 1 equals 0. So that's at x equal negative 1. I'm going to write it as a line, not as a point, where the intercepts are written as points. The asymptotes are written as lines. So I'm going to write that as a line. And then my last one is the horizontal asymptote. I want to do the limit as x approaches infinity of this function 3. I'm going to write the original function 3x minus 6 over x plus 2 in the unfactored form. I always think it's easier to find a limit from that. I go down to my lead terms. So then I rewrite that as 3x over x. When I simplify it down, I get 3, and that means I have a horizontal asymptote at 3. And when I write that one, I also write it as a line, but it's written as a horizontal line, where my vertical asymptote is written as a vertical line, x equals negative 1. My horizontal asymptote is written as a horizontal line, y equals 3. All right, again, like I say, it just seems like that shouldn't be enough stuff to get a graph going, but it really is. So I'm going to squeeze my graph in to the side. We're just doing sketches. So just know that these, when I graph them, I graph them like by putting the points in the right-ish place. You know, like I don't take it real too seriously or too whatever. I just put them in the right-ish place. So what I mean is right here, 2, 0, that's, I'm going to say that's like there-ish. Okay, and 0, negative 6, that's there-ish. It's below. Okay, so those are my 2 points that I graph, my x-intercept, my y-intercept. Then I'll put in my vertical asymptote at negative 1, and so then that's like there-ish. And you might be going, well, hey, that looks like the same. Oh, it doesn't matter. Okay, just make sure it's in the right position in the graph. Now, if this were a a vertical asymptote of 1, I'd have to make sure that I put it before 2. If it's 3, I have to make sure I put it after 2. If it's -1, I'm fine over here just being on that side of the graph. And then my horizontal asymptote is at 3, and so that's up here above, and I just put those as dotted lines. And now I just put my graph together. I draw my picture, and so I'm going to connect these points. That's how it's going to, there's nothing fancier that's going to go on between those. Those points are going to connect. I know that my end behavior or my asymptote says that this has got to come up, and as it goes far to the left, it's going to approach 3, so it's going to come and hover around 3. And then over here, this is going to drop down infinitely and just sort of approach that vertical asymptotes. That's how they work. Okay, now I have to figure out where the other piece of the graph is, and I know that it can't be up here because all these graphs are going to have 2 or maybe 3 pieces. This can't be up here because it would no longer be a function. It would fail the vertical line test. The other piece can't be over here because there is no other x-intercept that allowed it to cross the graph over there. So the only other place that this graph can be is up in this little region right here. And so I get sort of a flipped version, a flipped and moved version of the original parent function. So there we have. All right, so again, I took a little bit longer on that particular graph on the first one, but when we go through the next ones, we'll try and do them a little faster, and you can kind of see it in the action. If you need to pause the video and look back at it, great, go ahead and do it. All right, so in this particular, or this next problem, I cannot, there's nothing that I can factor there, so I am just going to jump right in. Factoring, the factoring section, it doesn't apply for this problem, so I always just, you know, whatever, not applicable, don't write anything. If you don't, I mean, you really don't have to write anything. So second step then is to go ahead and find my zeros. Again, that is when the numerator equals 0, so x plus 4 equals 0 when x is -4, so that is the point -4, 0. And for number 3, the y-intercept is when I find f of 0, so f of 0 is equal to 0 plus 4 over the opposite of 0 minus 3, which becomes -4/3. Oops, -4/3. I did a double negative there. For step 4, I'm going to set the denominator equal to 0 to find my vertical asymptote. I'll get abbreviate here, vertical asymptote. I get a little bit lazy sometime. Oh, I should go back and write this. This is 0, -4/3. That's where it crosses the y-axis. Down to the vertical asymptote, I set the denominator equal to 0. So I'm going to add 3, so -x equals 3, and then I'll divide by that -1, so x is -3. So that's the vertical asymptote line. I'm running out of room. Can I do it? I think I can. So my last one is I'm going to do the limit as x approaches infinity of this function, which is x plus 4 over the opposite of x minus 3. My lead terms, I end up with x over opposite of x. I simplify it down to -1, so y equals -1 is my horizontal, my HA, my horizontal asymptote. That is the end behavior, horizontal asymptote end behavior. So I'll go ahead and sketch my graph, put it all together on there. I just squeeze all the information in. So I've got a point here at -4, 0. That's my x-intercept. I've got one at 0, -4/3. That's down here. Again, it doesn't have to be perfect. You don't have to measure it out. That's a little bit more than -1, but I don't have anything else to put on with it, so it doesn't really matter. Other than when I put in this, my horizontal asymptote, I'm going to have to remember that this is a little more than -1, and when I draw that line, this line is going to have to be above it. But we'll get to that in a moment. My vertical asymptote is at x equals -3, which is to the right of -4. And again, my horizontal asymptote is -1, which is above -4/3. And so now I can go ahead and put my graph together, my little swoopies. Again, there really isn't a whole lot that can happen. I know it's got to approach the vertical asymptote, and it's got to approach on the right the horizontal asymptote. In this one I do have another point over here. It can't go above because it would not be a function anymore. I do have this other point that it's got to hit and cross through, so it's going to approach those asymptotes. I can't have a piece below because, again, it's not going to be a function anymore. So now I have my two little swoopies that make my graph. Okay, so sometimes funky things are going to happen, and that's okay. In problem number 3, we get one of those little issues, and in fact, tomorrow we'll get into some more of the issues. But in number 3, we have a situation where my numerator is just a number, and so I can't factor this. It's not factorable. But when I set my numerator equal to 0, 4 equals 0 for my zeros here, or my, yep, I should be labeling these, sorry, as we go, my zeros, 4 equals 0, well, that's never going to happen, so this has no zeros, meaning it never crosses the x-axis, no x-intercepts. So step 3 then is to find f of 0. This is again my y-intercept, f of 0. That means I put in 0 for x, and I'll end up with -1 when I do the math on that one. So that's the point 0, -1. So it does cross the y-axis, it just doesn't cross the x-axis. For number 4, I'll do my vertical asymptote by setting my denominator equal to 0, x minus 4 equals 0. So that happens when x is 4. And the last step I'll do is find my horizontal asymptote by taking the limit as x approaches infinity of this function 4 over x minus 4. Well, the lead terms on the top and the bottom leave me with 4 over x. That's bottom heavy, which means that my limit is equal to 0. That means I have a y, or a horizontal asymptote at y equal to 0. Okay, so I have everything I need. Again, it seems like it shouldn't be enough, but it really is. I'll sketch my graph and I'll put it all together. I have no x-intercept. I have a y-intercept at -1. I have a vertical asymptote at 4. And I have a horizontal asymptote at 0. So when I look at what I need to do for this one, again, this point is going to approach over here on the left. Both of those asymptotes, the horizontal asymptote at 0, it'll approach on the far left. As it moves towards the vertical asymptote, this will drop down to -infinity. I know that this cannot cross up through here because there's no opening for it to. Right here we figured out that there are no zeros. It never crosses that x-axis. Up in the problem above, it crossed only in that spot. That means it can't cross anywhere else. That's the only opening for the function to go through. So when I'm trying to figure out where everything goes, it sometimes is difficult to decide because right here there's nothing that tells me which position it's going to be. Well, typically, but not always, if it goes to -infinity on one side, it's going to go to +infinity on another side. And we'll learn tomorrow when that changes. There's when you have a double denominator or a vertical asymptote that falls in the same place, two of them that show up, that changes. But as for right now, it's going to be right in that upper position. They're going to go in the opposite direction. What you can do is, if you are not sure, just do a test point. So I'll just put something in there that is to the right of this vertical asymptote, say 5. When I put 5 in here, 4, I would get 4 over 5 minus 4, which is 4 over 1, or 4, meaning that 5, 4 is a point on this graph, and that means that it's got to be in that positive position. If it came out negative, then it would have to be down here in the negative position. But this one has to be in that positive position. Okay, so we're going to run through a few more, a couple little different instances that are going to happen. So here's problem number 4. Definitely I'm going to start factoring here. Let me see if I can get this to clear up blurry wise. I don't know if I'm going to end up causing an issue. Maybe, maybe not. We'll see. Sometimes once my hand starts going in there, it gets all fuzzy again. So we'll try. All right. So here we go. Here's our new function. Remember, the first thing that I said to you was factor if possible, and I can factor this one. So I'm going to go ahead and factor. I'm going to take out an x on the top, so that's x times x plus 1. And on the bottom, I'm going to have x. It looks like x plus 2 x minus 1. Factor however you need to do, but there's nothing in front of the x squared, so I'm just looking for two numbers that multiply to be negative 2 and add to be positive 1. And so that's positive 2 and negative 1. This isn't a lesson on factoring. I think we did a lot of that at the beginning of the year, so I'm sorry if I'm rushing through that. If you just have a question, let me know. But there's my factored form. I'm going to check to see if I can cancel anything out of this, and I can't. So I'll go on to my next step, and my next step is to find my zeros. My zeros are setting the numerator equal to 0, so x equals 0 and x plus 1 equals 0, which means that I have 0, 0 as one of my zeros, and I have negative 1, 0 as my other zeros. So this one crosses the x-axis in two locations. For step 3, I'm going to find my y-intercept, and on my y-intercept, remember that means that I find f of 0. That means replace everything with 0. So this is 0 times 0 plus 1 over 0 plus 2 times 0 minus 1. When I do the math on that, 0 times 0 plus 1 is 0, and 2 times negative 1 is negative 2, or just 0, which means my y-intercept is at 0, 0. Oh, well, I already had that point, so this point is just duplicating that. And that happens, especially, that happens in the origin. If the x-intercept is 0, the y-intercept is also 0, because the y-intercept, it can only cross the y-axis once, otherwise it's no longer a function. So my step 4 is my vertical asymptote. That means set the denominator equal to 0, x plus 2 equals 0, x minus 1 equals 0, so that's at x equals negative 2 and x equals 1. And then lastly is my horizontal asymptote, and that's where I take the limit as x approaches infinity of the function. I do it in the unfactored, unbroken down form. Just for me, it's easier to do it that way. I go down to x squared over x squared, my lead terms. This is neutral. It reduces down to 1. Y equals 1 is my horizontal asymptote. And so I'll go ahead and I will, again, put this together. What's different on this, maybe you already noticed, is that I have two vertical asymptotes. So let's put our points in. I have a point at 0, 0. I have a point at negative 1, 0. My y-intercept is the same, 0, 0. My vertical asymptotes are at 1 and negative 2. And then I have my horizontal asymptote at 1. Now the interesting thing that gets confusing to people when it comes to a horizontal asymptote is people think you cannot cross a horizontal asymptote. You can. You cannot cross a vertical asymptote, but a horizontal asymptote you can. And so you're going to see graphs where the graph may cut through that horizontal asymptote. The horizontal asymptote is only end behavior. So I don't exactly know how far up this graph goes, but I do know that over here on the far left, the graph has to be only in this upper portion because there is no place for it to cross the x-axis in the lower portion, and it would have to approach those asymptotes. So it has to be in the upper. Over on the right, it follows the same thing. Because there is no repeat in the denominator, we'll talk more about that tomorrow, I know that on the sides it's going to have to go in the opposite direction. And then my only last move that I have is to connect. Again, I don't know how high this goes up. Maybe it goes up and crosses through that horizontal asymptote, but these are just sketches and it doesn't really matter, so I'm just going to make it connect in my picture. And so there is my final graph on that one. We're cruising here, so now we've got another one where it looks like I can factor. So my step 1, factoring, I'll pull out a 2. On the top, x squared minus 4x plus 3 over on the bottom, I'm going to pull out a negative 1, x squared minus x minus 2. Then I'm going to factor that even further. So this is 2, if I can, obviously, and it looks like I can, x minus 3, x minus 1. two numbers that multiply to be positive 3 add to be negative 4. On the bottom, I get negative 1 times, I'm looking for two numbers that multiply to be negative 2, add to be negative 1, so that looks like x minus 2, x plus 1. I always scan through, is there any identical quantities that I can cancel? There is not, so there is my factored form. Step 2, find my x-intercept or my zeros. Remember, that's aka zeros. Don't ask me when I decide to call it what. I don't know. I don't have a good answer for that. Sometimes I call it the x-intercept. Sometimes I call it zeros. It really doesn't matter. It's also called roots. So there are different names for it. Whatever you call it, you do the same thing each time, and that is you're going to set your numerator equal to 0. So 2 equals 0, x minus 3 equals 0, and x minus 1 equals 0. Well, 2 will never equal 0, so I can get rid of that. Then this is x equals 3 and x equals 1, which means that I have two zeros. It's going to cross the x-axis twice, once at 3 and once at 1. So my third step is my y-intercept. My y-intercept, remember, is when I find f of 0. That means I replace all of my y-intercept is what I'm finding here. I replace all of my x's with 0. And so this is 2 times 0 minus 3 times 0 minus 1 over negative 1 times 0 minus 2 times 0 plus 1. And then when I do the math on that, it looks like 2 times negative 3 times negative 1 gives me 6, I believe, and negative 1 times negative 2 times 1 gives me 2, reduces down to 3, so this is at 0, 3 is my y-intercept. For step 4, I'm finding my vertical asymptote. Again, that's when the denominator equals 0, negative 1 I'll set equal to 0, x minus 2 will equal 0, x plus 1 will equal 0, negative 1 will never be 0. So x equals 2 is one of them, x equals negative 1 is the other. I'm going to have, again, two vertical asymptotes in this problem. So for number 5 is my horizontal asymptote. I'm going to do the limit as x approaches infinity of the function, which I'm going to go back to the original one, 2x squared minus 8x plus 6 over negative x squared plus x plus 2. Take my lead terms, which leaves me with 2x squared over negative x squared, reduces down to negative 2. So y equals negative 2 becomes my horizontal asymptote. So again, I know I rushed through that. Pause and catch up if you need to, but I'm going to just keep going and go ahead and get all this stuff drawn on here. I am going to plot my zeros at 1, 0, and my other one here at 3, 0. I'm going to put my y-intercept up here at 3. I have my two horizontal asymptotes, or sorry, vertical asymptotes at negative 1. And then this one's at 2. And so it's going to fall right between those two guys. And then lastly, my horizontal is down here. Okay? So now, I'm going to put this all together. Again, I keep things in mind. It just doesn't seem like this is enough, but just sort of keep these things in mind. Well, first of all, on the far left, I know that it can't cross through this axis because there is no opening for it, because there is no x-intercept or no 0 there. So this piece has to be down in this bottom corner, and it's got to approach those asymptotes on the far left and on the far right. Well, on the right as it approaches that vertical. On the far right, it's got to cut through the axis, and so here we have that little swoop. It's the middle part now that I have to figure out, make that look more like a smooth curve there. And so like I had said, most of the time if it goes up on one side of the asymptote, I can guess that it's going to go down on the other side. Now there are times when that doesn't happen. Again, it has to do with the denominator. When you have a repeat quantity in the denominator, if I had x minus 2, then around this axis it would go in the same direction on both sides. But I don't have that, so I know if it went up on one side, it'll go down on the other side. And then the 2 points here have to connect. And then if I look over here on the left, it's going down on the left-hand side of this vertical asymptote at negative 1. And so then it's going to go up on the other side. Now again, this is where people get bothered. Well, I thought you can't cross an asymptote. You can cross a horizontal asymptote. You cannot cross a vertical asymptote. Horizontal asymptotes have to do with end behavior. So there are functions that will go through this many times, and then the end behavior is where it will approach. You can cross horizontal asymptotes. You cannot cross vertical asymptotes. All right, so now we're down to our last problem, and we've seen the types of problems that we're going to get. We get, when we have the two vertical asymptotes, we could have it where we have just sort of like a parabola-ish thing in the middle, and then if we have two vertical asymptotes, we could have it where it has the little swoopy, almost cubed function or tangent-ish function in the middle, looking function in the middle, and then swoop is on the other side. And then we've also seen just where it has the flip on the upper left and lower right, or the flip on the upper right and lower left. So those are basically the different kinds of functions that you're going to see. Am I making you dizzy? Sorry about that. All right, so here we go. Last one. Again, like I say, there are going to be instances where funny things happen. And so number one, when I factor, the first thing that I'm going to do is I'm going to assign that negative in front up to the top. You can put it either way, on the top or on the bottom, but I almost always just assign it to the top. I think it's easier. I keep it consistent that way. The bottom, I have a difference of squares, so that's x plus 2, x minus 2, and so there's my factored form. For number 2, when I find my zeros or my x-intercept, I'm going to set the numerator equal to 0. That's never going to happen, so there are none. That means it's never going to cross, again, the x-axis. For number 3, I'm going to set or replace x with 0, so I get negative 4 over 0 plus 2 times 0 minus 2. That leaves me with negative 4 over negative 4, or positive 1. So that is 0, 1 for my y-intercept. For number 4, I'm going to find my vertical asymptote. Denominator equals 0, so x plus 2 equals 0, x minus 2 equals 0, so x is negative 2 and x is positive 2. And then lastly, I will do my horizontal asymptote. My horizontal asymptote, again, is the limit as x approaches infinity of this function. I'm going to go negative 4 over x squared minus 4, bring down my lead terms. That leaves me with negative 4 over x squared. I am bottom heavy here. Bottom heavy means that this is going to approach 0. Remember, we have top heavy, and then it's going to go to one of the infinities. We have bottom heavy, it's going to go to 0. We have neutral, where it reduces down. So this is at y equal to 0. I will find my horizontal asymptote. It's again going to give me my end behavior. So I'll get my graph ready and I'll put it all together. Here we go. No x-intercepts, y-intercept at 1. Horizontal asymptote at negative 2, just sketching it in, and at positive 2. Vertical asymptote at 0. Okay, remember when I said sometimes it just doesn't seem like there's enough for me to figure out what's going on here? This is one of those instances where I might say, boy, this is tough for me to see. I'm not real sure what's going on, because it can cross the horizontal asymptote. However, keep in mind, there are no points on this x-axis, so this point cannot cut through the axis because there are no openings for it, because there were no x-intercepts. So from that point, it can only go up. That's my only choice. It can't go down. It can't cross that. Because the numerator, or sorry, the denominator doesn't repeat, that means that if it goes up on the right side of this asymptote at x equals negative 2, it's going to have to go down on the left side. And if it went up on the left side at x equals 2, it's going to have to go down on the right side, unless we have that repeat. I would have to have x plus 2 and x plus 2 in the denominator in order for them to go in the same direction. So we really didn't have a whole lot of points to work with, but Just by knowing what we know, we can sketch the graph. If you ever get in a position where you're in doubt, go ahead and do a test point. So plug in 3. Do you get positive or negative? Because that'll tell you the region. Is it going to be the positive portion of the graph or in the negative portion of the graph? You can do just test points to put those in there. All right, so I know I talked really fast at record speeds, and I hope all went well. As always, if you have any questions, just contact me. Otherwise, have a great day. Happy graphing.